Okay. Good morning, here's today's starter. So it's an algebraic starter. So all it wants you to do is simplify both expressions. Different ways you can do it. So pause the video, have a go at simplifying those. So, no, didn't really do that. Right, here's your solution to the first one. So I've taken out a factor on the denominator, -1. I don't know why I've done it like that. What I could have done at the end, maybe I would have preferred to have written it out as 1 minus x squared all over 1 plus 3x. I quite like that. And my second one, so you can see it all on one screen. So maybe brackets around there. So that's my working out. Right. Today's lesson. So quotients. Okay, we know what a quotient is. Here's a good example of a quotient. If I need to differentiate a quotient, such as y equals x squared minus 4x plus 12 all over x minus 3 all squared, I could rewrite it as a product and then use a product rule. Absolutely fine to do that. However, sometimes I don't want to do that. Sometimes that's going to make my life harder, because I'm going to have to use the chain rule and the product rule, or there's another rule. And it's this other rule that we're going to meet today, the quotient rule. So the title of this lesson is the quotient rule. So what we would do with the quotient rule is, just as we were letting the product function of x, when they were multiplied together, we were letting 1 equal u and 1 equal v. They're now being divided. So we're going to let 1 equal u and 1 equal v. So in this instance, we would have u equal to x squared minus 4x plus 12 and v equal to x minus 3 all squared. And then we would substitute them into our formula. Now, the product rule, you will not be given the product rule. You had to learn it. However, the quotient rule you will be given. This is in your formula book or in your formula sheet. You'll be given this in the exam. However, it's kind of nice to know it so you don't have to keep looking it up. So what you've got is you've got v du dx minus u dv dx all over v squared. Shorthand, v u dashed minus u v dashed over v squared. And it used to be in the old A level that if you quoted this and then messed it up, you would get your method marks. We still advise you to quote that result. Bottom d top minus top d bottom all over bottom squared. Thinking of ways to help you remember it. So let's now do it. So let's differentiate this function. We know it's a quotient. It could be written as a product, but I don't think your answer is going to be as neat. And it does, the question does say, although I have appeared to have done my best to have chopped a bit of the question off here, so the question does say differentiate as far as possible. So I'm going to, first of all, I'm going to let u equal x squared minus 4x plus 12. And I'm going to let v equal x minus 3 all squared. And then I'm going to differentiate. So I'm going to get 2x minus 4. And I'm going to get 2 bracket x minus 3 all multiplied by 1, the derivative of the bracket. So I used the chain rule there. I'm now going to quote my quotient rule, v du dx minus v du dx minus u dv dx all over v squared. In fact, I'm going to use the shorthand one because I think this is what I would probably use. It saves time and does the job. So what I'm now going to do is substitute those in. So I'm going to get dy dx equals v, which is x minus 3 all squared, times du dx, which is, I'm now going to move that a bit over there, times du dx, which is 2x minus 4, take away u, which is x squared minus 4x plus 12, times by dv dx, which is 2x minus 3. So I'm going to put the 2 there and the x minus 3. And on the bottom, we're going to have v all squared. So x minus 3 squared all squared is x minus 3 to the power 4. So let's have a little look at what we've now got. I've spotted that each of these terms in the numerator has a factor of x minus 3. So I'm going to take out a factor of x minus 3. That's going to leave me with 2x, keep that there, 2x minus 4 and an x minus 3 minus 2 x squared minus 4x plus 12 all over x minus 3 to the power 4. I've spotted that I've got x minus 3 to the 1 divided by x minus 3 to the 4. So I can divide those. There is a product, so I can cancel. So my denominator will now become x minus 3 to the 3. And on my numerator, I've got, so I'm thinking would that factorise? I'm just going to expand it. So on the numerator, I've got 2x squared minus 4x minus 6x plus 12 minus 2x squared plus 4x, that's so not 4x, minus 2 times minus 4 is plus 8x and a minus 24. So simplifying this, you can see my 2x squareds are cancelling. I've got a minus 10x plus an 8x. So I've got a minus 2x and a minus 12 all over x minus 3 all squared. So I would like to say, what's that going to be? Minus 2x plus 6 all over x minus 3 all squared. Have I simplified that as far as possible? And let's check that that's correct. There it is. And yes, that's correct. That's what we're looking for, isn't it? So I'm just going to move that out of the way. I think I've simplified mine a bit more than the textbook did. So a lot of algebra, but only one new skill. The minute you've used the quotient rule, that's it, new stuff over. The rest is just your algebra and simplifying. So let's now look at our next example. Right, we said in last Friday's lesson, where I told you what the derivative of tan x was, that by the end of the following week you'll be able to prove it. So here we go. I'm going to differentiate tan x, and I can write tan x as sine over cos. I'm going to let u equal sine x, and I'm going to let v equal cos x. I'm then going to differentiate. I know du dx. If I differentiate sine, I get cos. And if I differentiate cos, I get minus sine. I'm then going to take my quotient rule. So v du dx minus u dv dx all over v squared. So I'm going to end up with dy dx is cos x times cos x minus u, which is sine x, times minus sine x. All over cos x all squared. So let's now gather that together. So dy dx is cos squared x, sine x times minus sine x, and you're taking that away. That will become minus sine squared x. So plus sine squared x all over cos squared x. And of course we know that cos squared plus sine squared from our year 12 work equals 1. 1 over cos is sec. So 1 over cos squared is sec squared. So you are now able to prove, so in fact it's the first of your trig derivatives that you are able to prove. You're able to prove now that the derivative of tan is sec squared. Right, hard question. So differentiate this, giving your answer in this form, where, so again, I've done that, maybe it'd be nice to see the where k, c and p are all integers. Now again, you've got to differentiate something. It's not chain rule because you've got more than that going on. You haven't just got a function inside a function. You've got something divided by something else. So you have got a quotient. So we're going to use our quotient rule. So u is x and v is the square root of x plus 1. So the square root of x plus 1, now that's great when I'm dealing with it with algebra and solving, but when I'm wanting to differentiate it, it's exactly what I don't want. That's what I want for differentiating. That's what I want for simplifying and solving. So what I'm going to do straight away is I'm going to differentiate these. So derivative of x, great. Here I'm going to use the chain rule. So dv dx, the half comes down and take 1 off the power. Now, do you want to leave it like that or do you want to simplify it back? So I've got a half, and of course that's 1 over square root of x plus 1. So I could write it back like that. I'm now going to take my quotient rule, which is v du dx minus u dv dx all over v squared. So I'm going to need quite a lot of room because this is looking quite unpleasant. So let's think about how we're going to do this. I'm just going to make sure I've got enough board space for it all. Right, I might even move that over there. So here we go. dy dx equals v, which is my square root, du dx, which is my lovely 1, take away u, which is x, times by dv dx. So that's over 2 root x plus 1. So you can now see why we did those unpleasant questions at the start of today's lesson. All over v squared. All all over v squared. Now v is the square root of x plus 1. If I square it, it's just x plus 1. Now that's remarkably similar. Let's have a quick go back to the starter. You know, it's remarkably similar to what you were asked to simplify there, but not quite. So let's now go back to our example. Too far. Right, here we go. I'm going to multiply top and bottom by the square root of x plus 1. I can do what I like, right, as long as I multiply the top and bottom by the same thing. That's just like multiplying by 1. So you can see what I really don't want to do is run out of battery. So I'm just going to quickly plug that in. It's like we're back in school. Right, I'm going to multiply the top and bottom by the square root of x plus 1. That means I'm going to move that a little further out of the way. So multiply this by the square root of x plus 1 and the bottom by the square root of x plus 1. Right, if I multiply this first term by the square root of x plus 1, I will get the square root of x plus 1 times the square root of x plus 1, which is just x plus 1. If I multiply this term by the square root of x plus 1, I will get, so if you imagine what's going to happen there, it's going to cancel with the divide by the square root of x plus 1, so it's just going to end up with a half x all over x plus 1 to the 1 times x plus 1 to the half. So x plus 1 to the 3 over 2. Let's see how this ends up. So I've now got 1x take away a half x, which is a half x plus 1 all over x plus 1 to the 3 over 2. Now it's so long since I started the question, I've forgotten what they'd asked me for this in. Okay, so they don't want it looking like that. They want this written back with a square root and a power there, and they want that to be an x with no number in front. So I've now got my answers correct, and if they just asked me to differentiate it, bingo, full marks, but they haven't. They're trying to make this more tricky. So the first thing I'm going to do before I deal with the half x is I'm going to deal with the denominator. Now I know that that can be written, it doesn't matter what order I do these in. It can be square rooted and then cubed, or it can be cubed, which is what I think they want, and then square rooted. So that's a rewrite of the power of 3 over 2. So some difficult year 12 indices work here. So I've got my square root and my power, and now I'm going to deal with the half x. So what I'm going to do is I'm going to rewrite that half x plus 1 as half x plus 2 over 2, which is of course another way of writing 1. And then all I'm going to do is I'm going to think I've got a half x plus 1 all over the square root of x plus 1 all cubed, which of course can be written as x plus 1 all over 2 square root of x plus 1 all cubed. So what I've done, and I think that was the hardest bit of the question. So differentiation was perfect. It's just they were very specific about how they wanted the answer. So I think you've now got your, was it C, K and P in integer form. So let's just go back and check that that's really what they were looking for under this lovely sunshine blob. Can you see what I've done? 2. I've just rewritten that plus 1. Of course, when I took out the half, I should have been left with a 2 there. So I'm really glad I checked. So let's go back to my final answer. Of course, that's a 2. Right, so check. We've got that correct. Yay, perfect. So we can now get rid of that one. It's just a long question, so try not to get lost. And as I've just demonstrated how easy it's to do, you've got so many numbers flying around, it's just so easy to just pick up the wrong one. You know, the x plus 1 there, suddenly you're reading off the wrong number, so do be careful there. Right, questions to do. So good practice. The more practice you can do with the differentiation rules, the absolute better, you know, and then questions 3 and 4. So again, find the coordinates so that you'll differentiate, put equal to 0, solve for the x value, but then you will get the y value by substituting back. And then question 4, do y dx, differentiate using the quotient rule. Don't be afraid of the a in there. Put that equal to 1, and you know it will equal 1 when x equals a. And obviously a can't equal -2. Find the value of a. So that's a bit more of a challenge. And here are your answers. See you on Monday. Have a good weekend.